Hi and welcome to Electrical Engineering Planet. In today's lecture, we will design and create an ATS circuit. ATS stands for Automatic Transfer Switch, which is used to automatically transfer power supply from its primary source, which is here the national grid or utility, to a backup source like generator when it senses a failure or an outage in the primary source. So as you can see here, this is our main supply or the primary source, and this is the backup source or generator. Here we will create a circuit that will transfer from the main supply automatically to the generator when it senses a failure or an outage. So let's start by creating the power circuit. Here this main supply is supplying power to residential loads. So we need here a three-phase power and a neutral. So let's start by creating this circuit by choosing electrotechnical IEC. Here from power source, energy sources, I will choose actually a three-phase. Here we have a three-phase and a neutral. Let's drag and drop it here. This is considered as the primary source. Also, I will bring a three-phase and a neutral from the generator. This is a three-phase power source generator. From protection, I will bring a power circuit. Let's here bring a 3-pole and a neutral circuit. This is our circuit breaker 1. This is the main circuit breaker for the main supply. And I will bring a new one for the generator. This is the circuit breaker for generator. Let's now bring two contactors, one for main supply and one for generator. Here I will choose a 4 poles normally open contactor. This is our first contactor. Let's close it for now. And this is our second contactor. Let's now connect our circuit from power wires, multiple wires. I will connect the three-phase power cables. Perfect. Let's zoom in a little bit. Now we still didn't connect the neutral. So I will bring one line connection and I will connect the neutral. Let's now connect the two outputs together. I will connect this output to the loads. So the power supply will come from the main supply or from the generator to supply loads. So here, 3 power wires, I will connect them to those coming from the generator. Also, one wire from one neutral to the second neutral. And those powers, I will connect them to the load. So this three-phase and neutral will be connected to the loads. Perfect. This is our power circuit. Now let's create the control circuit. Now we need a line and a neutral to create the control circuit. Here from power wires, I'll bring one wire. Here from any line from L1 or L2 or L3, I'll bring the line. This is our line. And here I will bring the neutral. So this is the power source for our control circuit. Here first I will connect a circuit breaker. This is a 1-pole miniature circuit breaker. I will bring it here from control, protection, and then 1-pole circuit breaker. Let's drag and drop it here. Let's delete this wire first. Here, right click on the circuit breaker and I will rotate it right. Perfect. Let's now connect the power source L3 to the input of the circuit breaker, and the output will be supplying our control circuit. Now I will bring a relay. This relay will be the most important device inside this control circuit. I will show you how. Here from relay coils, I will bring a relay coil. This relay coil will be connected to line and the neutral. So this relay actually will detect if the power source here is working well or there is an outage. So if there is an outage, this relay will not be working because L3 and neutral will not be working. So I will know from this relay if the power of the main supply is working well or not. So this will be considered as the most important device inside our circuit. Now I will bring a normally open contact from this relay. Let's put it here. Let's now connect the line to it, and then I will connect it to a timer. This timer will count for a specific time and it will make the contactor K1 to be working. So here from relay coils, this relay coil of a slow operation, this is a timer actually. I will drag and drop it here and connect it to this normally open contact. Now I will double click on this relay contact and I will tell our software that this relay contact or normally open contact is related to this relay KF1. So double click on it and I will tell it it's working with KF1. Okay. So now as you can see, this is called KF1. So now when this relay is working or this coil is working, this normally open contact will be closed and it will make this timer to start counting to make this contactor to be working. Now let's bring two normally open contacts to be in parallel with each others. The first normally open contact will be related to this timer, so double click on it and I will connect it to KF2. Press OK and perfect. So this normally open contact will be related to this timer. The other one I will make it to be connected to this contactor. But first I want to bring from here a contactor coil. Here this is our contactor coil. It's called here KF3. So I will make this normally open contact to be connected to it. So choose KF3. And now that's perfect. Now let's connect our circuit. Perfect. If this circuit breaker is closed and there is a power in our main source, this relay will be working. So this will be closed and this timer will be start counting. After a specific time, it will close this normally open contact, which will make the contactor to be closed. And this latched contact will be working now. So the power supply or the main power source will supply our load. Now let's see what if this relay stopped working, which means that this power source is not working. So now let's move on and see the control circuit related to this generator. Now I need a line source and a neutral from this circuit. First of all, I will bring a normally open contact from this relay and I will put it here as the main source of this circuit, control circuit. Let's see exactly how I will do this. From contactor, relay contacts, I will bring a normally closed contact and I will make it related to KF1, which is our relay, main relay. Let's rotate it here. Now let's bring L1 as the line, and here this is our neutral. Let's bring it here as the neutral for our circuit. So as you can see here, this, if it's open, it will open the control circuit for this circuit. So if this relay is working, which means that there is a main power source here, it will open the circuit for the control circuit of the generator. We don't want this generator to be working. Perfect. Now let's bring this line wire and let's create our control circuit for this generator or backup circuit. Here from relay coils, I will bring a timer T2. This timer will count a time before it makes this contactor work. Now let's connect it to the neutral, and the line, I will connect it to a point or normally closed contact from this contactor. We will know exactly why now. Let's connect our circuit now. Here from contactor coils, I will double click now on this contactor and I will link it to this coil of the contactor. So double click on it and I will call it KF5. So now this coil is related to this contactor. So now this normally closed contact, I will call it also KF5 because it's related to the contactor. Here I will bring two normally open contacts to be parallel to each other. One of them is related to this timer. Double click on it and let's call it what as the name of this timer, which is KF4. KF4. Okay. The other point will be related to this contactor, which will be a latched contact. So double click on it and I will call it KF5. Now let's connect our circuit. Those will be in parallel and let's connect it to the coil of the contactor. And as you can see here, this is our circuit. So let's trace our circuit now. What if we close this circuit breaker at the beginning and this contactor is still not working? If there is a power source here, this relay will start working, which will open this relay or this normally closed contact, which will make this control circuit not to be working. Let's get back here. This relay, when it's working, it will close this point, which will make this timer to start counting. Let's say that this on delay timer will be working after 10 seconds. So after 10 seconds, it will close this normally open contact, which will make the contactor to be working. So the power will move on and go to the residential loads. And this normally open contact from the contactor will be also closed. Now what if there is an outage inside this circuit? Now this relay will be opened. So it will become here normally closed. So the power will start supplying this circuit. This timer will start counting. On delay timer will start counting. Let's say for example we give it 10 seconds. So after 10 seconds it will close the circuit to make this circuit breaker or contactor closed, and this will be latched to be continuous working for this coil. So the contactor will be working, so our generator will start to supply our circuit. Perfect. Now if the main supply return it back, it will make this relay to detect it's returned back. So it will open the control circuit. So this coil of the contactor will not be working, so it will open the contact of the contactor, so the generator will not be supplying the load. Now this relay, when it's working, it will make this timer start counting, and after a specific time it will make this coil of the contactor working, and when this contactor is closed it will start supplying the loads. So those timers are important to ensure that the main power supply and generator will never work at the same time, and also it will ensure that the main source has come in a stable way, because sometimes this main supply become on and off, not stable. So this timer will ensure that this main supply has come for a specific time, and it means that it's stable. Then it will make it supply the loads. Perfect. Now I will ask you a simple question. What if this relay has a problem? It's not working well. It could make this contactor work and also at the same time make this circuit work, which will cause a huge problem and a huge short circuit, because there is two different sources are connected now to each others. So to ensure that this will never happen, we have to make an electrical interlock, as we did in star delta. So we can create here a closed contact from this contactor, and here a closed contact from this contactor, to ensure that they will never be working at the same time, even the relay is not working well. So let's now delete this wire and this wire, and I will bring two normally closed contacts. This is the first contact, and I will call it KF5. Let's double click on it. KF5. Now let's connect it to our circuit. Here I will bring another one here and call it KF3. Now let's connect it to the circuit. So now our circuit has an electrical interlock between each others. Before we simulate our circuit, let's give time to this timer and this timer. I will give it only 10 seconds to make this circuit to be simulated in a very fast way. And from here, electrical characteristics, I will choose only 10 seconds. Press OK. And let's check on this delay on operate. See if it changes. Let's double click on this also timer, electrical characteristics, give it 10 seconds and check on delay on operate. Press OK, press OK, and now perfect. We are good to go. Now let's simulate our circuit. Also, we forgot to make this contactor to be related to this coil. So let's call it KF3. So as you can see, this contactor now is related to this coil. Now let's simulate our circuit. Let's close those two main circuit breakers first before we simulate our circuit. Now if we close this circuit breaker, this relay will start working. This is our key device. When it will work, it will open this. Let's see. As you can see, it's working now, and it has opened this contactor, and it makes this timer to start counting. After 10 seconds, it will close this point to make this contactor work. And as you can see, this contactor now is working, and this is latched contact, which will make this contactor will make the power to supply the load. And this circuit is opened, no power source coming from the generator. But what if there is an outage here in this power source? Let's simulate it by opening the circuit breaker, which means that there is no power source here. This will make this relay to be opened, which will make this circuit to be closed and this to be opened. Let's see. As you can see now, it has been closed and this supply has started to supply this relay, and after 10 seconds it will make this circuit to be closed. And as you can see, this coil has been closed and this contactor is working now, and the power supply is coming from the backup source or the generator to the loads. Perfect. If the power source have come back, as you can see, this relay have been closed again and open this control circuit, which make this relay to be closed. And this contactor started working after 10 seconds and the load is coming from the original or the primary source. That was it for today's tutorial, and in the next tutorial we will learn how to break any induction motor with different methods of braking, like plugging method and the other method of DC injection. So stay tuned and consider subscribing to Electrical Engineering Planet channel to support our community. Also, don't forget to share, like, and let knowledge enlighten your world. Thanks for watching.